let me talk to you right now about how we deploy this to your environment. Because after all, the objective is to get people into their webmail. They do not really care about authentication. That's our jobs, is to make it secure for them. The end user's experience is like this. User hits the Outlook Web Access server. The server is configured, and I'll show some slides on that, and very simply so, it's a configuration. Configured to take the authentication and redirect the user to the multi-factor corporation SecureAuth module installed on a server. And that server is trivial. It's just an IIS server running on Win 2003. It could be Win 2003 web server edition. That authentication occurs as I discussed previously. What the SecureAuth module does is inspect the left-hand side, inspect the user to see if he has a valid X509 certificate. Now what's important here is what we do during this process is install a lightweight plugin to the browser. That it could be a plugin to the Safari, Firefox, or IE browser. The reason for this plugin is that users do not understand client-side SSL. It's just a given. I worked at RSA in the 90s, and so does many of our team members here. They simply don't understand what a certificate is, nor do we want to go through the pain of telling them how to import, export a private, public key, etc., etc., etc. Our client module does this for the user. If the user does not have the certificate, we ask the end user, and we being the SecureAuth module residing on the server, ask the user to register. And that is a configurable option for the deploying administrator, which registration methods you would like to use. And as discussed, it can be SMS text to his cell phone. It could be a phone call delivering a one-time password to any phone, LAN or cell. It can be an email, or it could be a static PIN that is inputted via a keylogger proof JavaScript keypad. In this scenario, in the demo I'll show you, the user selects telephony. Then what we do is we do a secure WSE 3.0 authenticated web service call. And if you're not familiar with WSE 3.0 standard, what it literally does is take a certificate authenticated with the private key authentication to our web services. Why is that important? Well, you as a customer should care that we only let valid customers use our web services, because that's the only one that can get a one-time password or a certificate from us. In this scenario, what we're doing is we're calling the end user and giving a one-time password. Once this is done, what we then do is we inspect the user to ensure that he still exists in the data store of record. This is a very important distinction in our product. If you're saying, well, Garrett, where do you store users? My answer to you is multi-factor does not store users. We don't do that. Our product is about delivering a certificate and then authenticating the certificate, which I'll show you in the second part of this presentation. The data store of record is yours, is you being the enterprise. It's your Active Directory. And guess what? The fact that you have OWA, you already have an Active Directory, and it's very happily populated with users. Therefore, why don't we do something intelligent as an authentication company and use your pre-existing user information? So what we're doing here is validating that user exists and validating that user's password. If that is done, what we're going to do is create a PKCS 10 message request from the client side. Like I said, our plugin, our browser plugin, not only inspects to see if there's a certificate there, but it also creates a PKCS 10 message request that is relayed. That is then signed by our CA server and pushed down to the end user into the native key store. Why is that important? Because if we were talking about other products such as SSL, VPN, and all that, they have areas where they're looking for the key store. Unlike some competitors, we do not go off and recreate the wheel. We put the key store where entities and enforcement points are looking for the keys. In the IE browser, as I was showing in the demo, we store it in the Microsoft non-exportable key store. Once this is done, the user meets his objective. The user gains access to the Outlook web access. That is what we call the enrollment. Second part of the equation is absolutely unique and occupies many of the 9 filed patents we have in this solution, is about access. Now, as I said when we started this call, you said, Garrett, you're doing client-side SSL, you're pushing down a certificate. Many of you who have experienced PKI would say, Garrett, the real problem is once you give that certificate, I got to take my application and I've got to convert that over to client-side SSL authentication. It's not a trivial task, and it's not a trivial task for Outlook web access either. There's like 32 pages in the last document I saw about that. Well, good news. No one on our staff reads that document because we don't utilize client-side SSL. We redirect the user to our SecureAuth module, which does a validation of the certificate and mitigates the man-in-the-middle attack. Let me, without revealing too much, and we can reveal more of our NDA, what exactly we're doing. In the access part of the product, what we're actually doing here, and this is pretty neat and fun to explain to people, what we're doing is taking information from the pre-existing cert that lives on your SSL server. Now, if you say, Garrett, this sounds cool, I can do this for all my other applications. Exactly, that's the point of the call. Is that what we're doing is taking a pre-existing certificate, not delivered from us, but I don't care where it comes from. It comes from GeoTrust, Entrust, RSA, etc., and we're grabbing cryptographic information from that. Our client is grabbing that information and then signing it with the private key that we sent down. Why would you do that? Well, the whole idea is I want to find out what server this is. And any PKI, and I read all the blogs and all that, they say, well, you know, the way to stop phishing is to educate the left-hand side. We got to tell these people they should look at the certificate and they should find out which server they're actually passing their credentials to. You and I both know that's absolute fantasy. We all have mothers. They wouldn't know what a certificate is to save our lives, right? So what our product does is does what an experienced security engineer knows to do, to look at a certificate. We do that automatically. But to validate that, it needs to be signed by the private key and done with a hashing mechanism, so it's not modified by the evil, nefarious attacker. That is the a part of the rocket science of the product. In addition, we grab the web URL, and we do something pretty nifty too. We create our own certificate request ID inside that with a private key. That way, we validate that there's not a follow-on attack. Now, there's other pretty nifty stuff we do as well that I just don't want to reveal on a public call. But the point of this to understand for the members of this call is that not only are we unique in our ability to push out our certificate, but we're unique in our ability to actually validate it in a well, basically a technically trivial way. Combined, the solution mitigates the man-in-the-middle attack. You can say, well, great, Garrett, what I could do is I can do this ourselves with our engineering lab. Yeah, in theory you could. As long as you're ready to turn on client-side SSL on your OWA server, which is only, like I said, 32 pages and breaks everything else on your web server. Create your own CA, create your own certificate stores, create your own anti-database, which is a certificate revocation list, and oh, by the way, figure out how to do one-time passwords over telephony or SMS, and then manage those servers. This is exactly what our solution in a single box, in a single module, delivers to your enterprise.